Hello, ladies and gentlemen. Time for a little lesson about positive intervals and negative intervals for a function, and also dealing with minimums and maximums. So this is the assignment that we're going to be working with. But before we dive in, once again, we're going to talk about what graphs mean in real life. And so this is a guy lovely graph here. It's titled The Submarine. You might have seen this before, but Captain Gerald just invented a brand new submarine that can go both underwater and fly in the air. So pretty good. He's did a test run, and this graph shows the elevation of this submarine during those 20 minutes. Okay, and so we're going to answer a couple questions. I'm a little bit less worried about this. What's the elevation at 0 mean? This is going to be the water level. And then what's the deepest it goes is down here. So that's going to be -7. But this is the elevation is in hundreds of feet. So this would be -700 feet. Or just below water, 700 feet. Okay, so we got a lovely graph here, and we got a couple questions we're going to answer about it, which is, during what time periods was this submarine underwater? Well, as I look through here, here's my water level, 0 there. So it's underwater here, and it's underwater here. So I got a couple of them. So this first one goes between minute 2 and minute 7. So I got, not -2, just between 2 and 7 minutes. And then my other one starts here at 14 and ends at 20, ends at the surface there. So we got 14 to 20 minutes. Nice. Okay, so it's under the water here, underwater here. And then we got the next one. During what time periods was the submarine above the water? Well, here we got on the water, below the water. This one. This is above the water here. So this section. Once again, we're going to write down our minutes during what time periods. That's going to start here at 7, and it ends at 14. So it's going to be from 7 to 14 minutes. Okay. So yeah, the submarine is underwater, shoots up in the air, comes back down, is underwater again, and comes back to the surface. So cool little demonstration there of this fancy submarine. So the point of doing this little exercise, going through and reading a graph and realizing what it means in real life, is because these two things that we just noticed and wrote intervals for represents where this function is negative, meaning below my x-axis, and then positive, meaning above the x-axis. So positive means above the x-axis, negative means below the x-axis, or the y values here are negative. Y values are negative, and here the y values are positive. When this function is just sitting at 0 here, we would say as well, it's not positive or negative on 0 there. It's just 0. And so this is what you're going to have to identify about functions on your assignment. And to write your answers, it's going to be really similar to this, except you don't write 2 to 7 minutes or 14 to 20 minutes. You're going to write it as an interval. Luckily, the interval is really easy to write. You just put the first part where it started, and then you write down where it ended, that particular property. So it's from 2 to 7, so you put 2, 7. And this one is 14 to 20, and there's our interval there. This last one, it goes from 7 to 14 minutes. It's positive from 7 to 14 minutes, so I put 7, 14. And that's where the function is positive. And that's the case for this function up here. And so that's what's going to be going on during your actual assignment. You're identifying where the function is positive and where it's negative. It's also asking for things like intercepts and maximum minimums. We're going to talk about those next. But first, let's talk about positive and negative. So a quick reminder, if a function hits the edge of our visible area, we're just going to assume it keeps going. Just assume it's got arrows there. And as I look over this function, I need to figure out where is it above the x-axis and where is it below. So this is above and this is below. Well, it switches right here. This whole section here is below the x-axis, and then this section here, everywhere to the right of that, is all above. So the positive interval is going to start at this number, which is a little bit difficult because here's 1 and 2. But, if you count your tick marks, you can figure out it's 1, 2, 3, 4, 5, 6, 7. Oh, it is 1.7. So it starts being positive at 1.7. And then everywhere to the right of that, it's all positive. So like as you go right along your function here, as you go up and right, it is all positive for the rest of forever. And so if you go right forever, that is the direction of positive infinity for your x's. So there you go. There's my interval where it's positive. The interval where it's negative is over here. Well, it started being negative. It was negative, 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 and then it stopped here. So it started being negative on my left side. So on the left side, that's going to be negative infinity. And then it stopped being positive there at that same point there, 1.7 for my the intersection here where it crosses over. So there you go. That's how you write your positive and negative intervals. Let's talk about the other parts on here. It's also asking where the x-intercepts or the y-intercept. So x-intercept is where it crosses the x-axis. The y-intercept is where it crosses the y-axis. Let's start with the x-axis, the x-intercept, which is at this point. We already mentioned what it was and where, that it crosses from negative to being positive. So that is my x-intercept. When you write down your x-intercept, I would you like for you to write the point and not just the number. So the point is at 1.7 comma 0. And then the y-intercept is where it hits the y-axis here, which is at this number being negative 2. So I'm not going to write just negative 2. I want you to put the whole point. The point is at 0, negative 2. So there's your y-intercept. Some functions have more than one x-intercept. Like this one, you got an x-intercept here and here. So you're looking at negative 1, 0, and then at 3, 0. So just be aware sometimes there's multiple. And now we're going to talk about the last two blanks. It's mentioning minimum and maximum. We really didn't talk about minimum and maximum last year, so this is kind of a new thing. But minimum and maximum just means the highest point or the lowest point. But the thing is, there's different kinds of minimums and different kinds of maximums. If a point is the highest for the whole graph, like it's the biggest point or the lowest point, it's called an absolute or local minimum or maximum. But if it's just the highest or lowest point in the surrounding area, it's called a local maximum or a local minimum. And so as I look at my function here, I do have a highest point and I do have a lowest point. But it's not the highest or the lowest point in the whole graph, right? All of this is higher than this thing, and all of this stuff down here is lower than this one. But these are two local minimums. Two local minimums and maximums. So we got local min, local max, and local min. But we're going to write these as a point, just like our x-intercepts and y-intercepts. You write as a point. So you got this point here, which is a little tricky to find out exactly where it is. Let me go up here, snap it. Yeah, it's looking like about 0.1 there. So I got my maximum there of 0.1, and I have to write the y value there, which is negative. Looks like negative 1.9 to me, negative 1.9ish. Sometimes you have to approximate things, so that's my best approximation for right there. And then I got a point here. This one is at a nice intersection. The x value is 1. The y value is negative 3. So we're going to go to 1, negative 3. So there you go. So some functions have an absolute or global maximum and minimum, or minimum. And then some functions have local ones. Some functions may have like a local maximum and a global minimum. That can happen too. Just if it's the highest in the area, it's a local. If it's the highest for the whole graph, it's a global or absolute maximum in them. And on your assignment, you should take a quick note. It's like, is a local or global or absolute on those, and that'll help you just kind of remember as you go through what type it is. Okay, let's have you jump to number 3 and see if you can answer these real quick. Go ahead and pause the video and give it a shot. Can you write down the positive and negative intervals, the x-intercept or the y-intercept, and the minimum maximum? All right. So let's go ahead and check and see how things went. Do a little, yeah, if you got things right, trying to disturb your neighbors. But yeah, the positive interval. Well, this entire graph is above my x-axis, which is down here. And so it's positive everywhere that this function exists. So everywhere to the right. But on the left side, it actually stops here, which is my x value of 3. So I actually need to stop my interval there. Starts at 3. And since this point is above the x-axis, we're actually going to have a square bracket on it. Yeah, a little bit different, but it doesn't hit the x-axis there being 0. It is a positive y value of 2. And so there's my positive arrow. And since it's positive arrow and that means it's negative nowhere. And so we could put NA or none. There are no intervals where it's negative. Moving on to our x-intercepts, it doesn't hit the x-axis. So again, we're looking at NA or none. And y-intercept, again, this function doesn't hit the y-axis at all. So I'll put none this time. We'll switch it up. No intercepts at all. It's just out in the first quadrant there. And now it's time for our minimum and maximum. So this one is a global or absolute one, and it's this point here. This is the lowest point for the entire function. And so we're going to write that point. It is a global minimum, and that point is at 3, 2. This function does continue to go up and right forever, and so it does not have a maximum, and so you can put none or NA on that. So there you go. So that's what's going on with positive, negative, intercepts, and maximum minimums. You just have to know some of the definitions for stuff. Let's jump to one last example, which is just taking a moment to graph the function that has these properties. I'm going to give you a couple tips. First things first, if there's any points, graph them, because you know it has to hit those points. So I got a maximum at 2, negative 2, so I'm going to put that point, and it has a y-intercept at 0, negative 6. And then it also says it is negative from negative infinity to positive infinity, so it never hits my x-axis. It's all down here. You just need to draw any old function you want that hits these 2 points and doesn't. Oh, one of these was a maximum. Sorry, max. So this has to go up and down from there. And so, yeah, I just need to make sure that is a maximum. It doesn't say whether it's global or local, and so I'm just making it global. You can decide, right? You can come up and down like this if you wanted to, but I'm just going to make it a global maximum there, and there's my function. So I recommend starting with points and then figure out max mins where things can go up and down. But there you go. Good luck with your assignment.